Hi students, today we're going to learn about input-output table. Please write it down in your journal, the title of the lesson of today. Just the red letters, the red words, input-output table. Now, I use this manipulative in order to explain to you what is the idea of an input-output table. So let's do it. Suppose you have the number 8 and you're going to process the number 8 into the table. So you put the number in. That's why the word is input, in. And when you put the number in, the process is according to the rule. This is an additive pattern, plus 12. So what is going to happen inside? 8 plus 12. And what's the answer? What is the output? So the output is 20. One more time. Input 8. Rule plus 12. 8 plus 12, 20. Now, another example, another input-output table. Minus 26. So this is a subtraction. Now we use the minuend 80. 80, and we're going to put inside or input the 80. Input the 80. Inside is the process of the 80 minus 26. Sometimes this algorithms are a little bit difficult, so maybe you have to use your journal. So how much is 80 minus 26? Standard algorithm of subtraction. Minuend minus subtrahend equals difference. So what is going to happen in the output? The output is going to be 54. Input 80, output 54. Rule minus 26. Another example is when we multiply as a rule. So the rule is times 5. Now let's use a simple number like 4. I'm going to put the 4 inside, input, 4 times 5, output, 4 times 5 equals 20. This is a multiplicative pattern. Now the rule is divided by 3. So use this number, 27 divided by 3. So input the 27, input inside. Now outside, the output is going to be 9. And that's the basic for the idea of an input-output table. Now I want you to discuss about what you just have seen, and talk to yourself, and then share with the class. So speak your mind. Now we are back. Let's do some real life examples. What are we doing today is learning about input-output table. Real life examples. Suppose you took a test. Now this test has 10 questions. How much you can get? 100. You can get 100. But you answered today 8 correct. 8 out of 100. What will be your grade? Yes, your grade will be 80. Easy, isn't it? And that is an example of input-output. How do you know your grade is 80? Because you know that each question is worth 10 points. And that's the rule. Let's do the math. This is the table, the input, output. Analyze the table. So this column here is the order, the position of the numbers. In the middle is the rule. The rule here is times 10. So the position times 10. The second position times 10. Number 3 times 10. How much is 4 times 10? 40. 5 times 10, 50. You got 8 correct. So 8 times 10 is 80. So as you notice, you were using your input-output table since, I don't know, first, second grade, third grade. Now you know what's the name of this process, of this table. You got 8. So calculate your grade. 8 times 10. 8 times 10 is 80, and that's your grade. One more time. Vocabulary for the lesson. Input. That's the input column. This is the rule in the middle. We also call it the numerical expression. 1 times 10 is 10. That's the numerical expression. Remember, in the center is the rule. And this is the output. This one and this one, everything in this column, we call it the output. So remember that this column here, we call it the position. The position. We can say that the rule here is input times 10 if we use words, or input times 10 if we use the sign of multiplication. Now, notice that not every table starts with number 1. This is a table that starts with number 8, but the rule is the same. 8 times 10 is 80. 9 times 10 is 90, and 10 times 10 is 100. So here, 8 times 10, the output is 80. Now, let's do some examples. What is your favorite junk food? Maybe. Now, suppose each bag of Takis is worth $2. The price is $2. Now, look at the table. What happens if you buy 3 bags? You have to multiply 3 times 2 because each bag is $2. What happens if you buy 5 Takis? 5 times 2. 7 Takis. 7 times $2. Now, complete the table. What is the output? 3 times 2 is 6. 5 times 2 is 10. 7 times 2 is 14. Now, some examples of questions. Each bag of Takis costs $2. Now, the instruction is complete the following input-output table by filling the blanks. There's a table, fill the blanks. The rule is times 2. 3 times 2 is 6. 7. 7 times 2, 14. And 9. 9 times 2, 18. It was about multiplication. Now let's do one about adding. The rule plus 49 is used to show the relationship between the position of a number in a pattern and the value of that number. The question is, which table shows this relationship? Okay, let's analyze one by one. Option A. Remember that the rule is plus 49. Now, in option A, we see the position is 1, 2, 3, 4, correct? And the rule is plus 49, which is correct. Now, how much is 1 plus 49? 50. 2 plus 49, 51. 3 plus 49, 52. 4 plus 49, oops. 4 plus 49 is 53. So here is a trick. Here is the trick. They are trying to pull your leg here with the addition. Be careful. So maybe in option A, if you only add the first, the second, and the third, you can see that's my answer. But no, you have to complete everything. You have to check everyone here. So option A is incorrect because of this number. Option B, position 50, 51, 52, 53. This is correct. Expression plus 0, plus 0, plus 0, plus 0. Hey, remember that the rule is 49. Return to the question. The rule is plus 49. And here the rule is plus 0. So because of this mistake, option B is incorrect. Let's do option C. 49, 49, 49, 49. Hey, what's up here? 49, 49, 49. Nuh-uh. That's wrong. The position should change because the pattern is plus 1, plus 1, plus 1. Now observe that one addend here is 49. 49 plus, 49 plus, 49 plus. So the rule is correct, but not the position. So this option C, the table is incorrect because of the position, which is the same. Now, option D should be the correct one. Let's do it. 1, 2, 3, 4. Yes. Expression 1 plus 49, 2 plus 49, 3 plus 49, 4 plus 49. Correct. Value 1 plus 49, 50. 2 plus 49, 51. 3 plus 49 equals 52. And 4 plus 49 equals 53. So option D is correct. Everything here is right. Final answer, C. An input-output table where the rule is subtraction. Now, the rule minus 16 is used to show the relationship between the position of a number in a pattern and the value of that number. Which table shows this relationship? Now, they are asking you to analyze the table. Which table shows the relationship? So you have to find 1 which is correct and 3 incorrect. So analyze option A. Position 5, 6, 7, 8. Remember that I said previously that it shouldn't start always with number 1. Could start with another number like 5, 6, 7, 8 is correct. So return to the rule. The rule is minus 16. Now look at the expression. 21 minus 5, 22 minus 6, 23 minus 7, 24 minus 8. What happened here? The rule is incorrect, correct. Now the value could be correct. If you subtract this, 21 minus 5 equals 16, yes, but the expression here is incorrect. So option A is wrong because of the expression. Let's do option B. Position 21, 22, 23, 24, correct. Expression plus 16, plus 16, plus 16. Hey, do you remember the rule? Return to the question. The rule minus 16 is used. Oh, so here the expression is also incorrect because it's adding instead of subtracting. So option B is incorrect. Let's do option C. Look at the expression. Minus 16, minus 16, minus 6. So the expression is correct. The rule is correct. What happened with the position? 21, 22, 23, and 24, correct. Now do the value. 21 minus 16 equals 5? Yes. 22 minus 16 equals 6? Yes. How do you check this? Because you check a subtraction with an addition. So add the difference, 5 plus 16, and you get 21. 6 plus 16, and you get 22. 7 plus 16, and you get 23. And finally, 8 plus 16, and you get 24. Now, it looks like this is correct. Option C. Now let's do option D. Position 16, 16, 16, 16. Hey, there is a mistake here. They tried to pull your leg here with the position. Be careful. So option D is incorrect. You don't have to look at the rest. Position is incorrect. Maybe the expression, no, and the expression is also wrong because they put 16 minus 6 instead of 6 minus 16. So option D is incorrect because of the expression also. Not only the position, but the expression. Final answer, C. And this is everything about input-output table for today. Bye, students.